Okay, so we have been discussing digital circuits, and we have already talked about one of the branch of the digital circuit is the combinational circuits. In combinational circuits, output is a function of input. Whatever the input value is directly reflected at the output. Okay. Another thing, another important branch of a digital circuit is the sequential circuits, in which output not only depends on the input, but also at the past inputs, the current input, but also the past inputs. So in combinational circuit, whatever we apply at the input, it is processed in the combinational circuit, how many number of gates, whatever the circuit is, and then it is reflected at the output. In sequential circuit, it's composed of the combinational circuit, which means that we have this entire thing here, and an additional component, which is the memory element. And the memory element helps us store the information about the past inputs. Okay? So in this sequential circuits, there are again further two types. This is just an additional information, just for your understanding. So there are asynchronous circuits and synchronous circuits. In the asynchronous circuits, the output circuit depends on the present input signals at any instant of time and the order in which the inputs are provided. Similarly, in synchronous circuits, the output basically is a function of input signal at a discrete instant of time. In other words, the synchronous circuit you may consider as clock circuits, where we count the time, the instance, any given instant of time, also in deciding what would be the output of the circuit. So sequential circuit consists of a combinational circuit and the memory element connected with the feedback loop, because the output of the combinational circuit not only depends on the current input, but also the past state, which is the feedback coming from the previous state. Okay? So whatever the output was produced, it is stored, and the next output depends on the previous state and the current inputs. Okay? This is just a logical diagram for the sequential circuits. And the output in a sequential circuit are function not only of the inputs, but also of the present state of the storage elements. And same is the case with the memory elements. So the function is not only the next state of the memory element is also a function of the external inputs and the present state. Okay, so we have clocked sequential circuits. So you see the difference between this diagram and this one is only an additional clock pulse. So in practice, we need to synchronize the activities or synchronize the outputs, multiple outputs in our real circuits. So let's take an example of let's say a card reader. When you enter in the campus, you tap your card on the card reader, and instantly three things happens. What are those three things? What do you see on the card reader? Yep.
I see my code thing turning, essentially being typed in. If there's a screen connected to it, I see it. I see it reading it.
Yeah, it reads the data. If there is a LCD screen connected to it, this is what you're saying. Yeah. And if it is not, like you're just tapping your card to enter the building, so what happens? Other than if the screen is not connected.
There's a noise.
As a buzzer which beeps, teent, teent, like this, and the red light turns into green, which shows that the lock is open, and actual lock is open. So there are three things that is happening, okay? And there might be another thing that which is logging the activity who is entering in the campus. So all these three things have to be synchronized. How do you think a computer can synchronize these activities? So there is a clock signal which we are going to discuss. This might be a first concept, first time you will be hearing about this concept. So just like we have to synchronize an activity, if you are given a task, let's say I give you an activity, the class activity, and I ask you to complete it in certain amount of time, let's say 5 minutes. So how do you compare whether you are on track? What would be your point of reference? How would you compare that you will finish the task within the allocated duration? what will be your point of reference? So if you're given a task to complete within a certain time, so you have to keep track of what? The time. And how will you do that? By just watching clock. So you have a point of reference, number of minutes or the number of seconds, or in other words, like you have to identify that whether you are able to complete number of exercises within 10 seconds or like 100 seconds or something like that. Have you ever tried monitoring your activity based on, let me give you a very silly example here, based on your breath cycle, the number of time you are breathing. Like how do you, when you breathe, like inhale and exhale. Have you ever tried monitoring your performance, your progress, based on like, oh, I was able to complete a certain question within 10 breath cycles? But this happens in computer. Okay, so computer, we have to talk about like how computer completes their activity within certain number of cycles, and that is what we call the clock cycle. So the clock signal is commonly denoted with an identifier called CLK or clock, simply clock.